Dear friends, today we are going to continue the problems on Poisson distribution, part 2. So in the first part of the video, we learned what is Poisson distribution and why we need Poisson distribution and what are all the situations we are going to apply Poisson distribution. We know that the key point Poisson distribution is what? Distribution for rare events. And we learned lambda is equal to np, it is uniparametric. Okay, so when n is getting very large and my probability of success is getting very low, it is trying to approach 0, then what can I do? I can apply Poisson distribution. Okay, let's go into a new problem. So what they are selling, a company has 2 cars. Okay, so they are giving rent 2 cars. So the demand of the car on each day is distributed as Poisson variate. Very good. So they say that the mean is 1.5. So immediately we know mean is what? NP, that is nothing but my lambda. Very good. So lambda is given directly. What we have to find? We have to find the proportion of days on which neither cars are used. So none of the cars are used. That is the first point. And the second point, some demands are refused. So it is going to be very easy, guys. Okay, let's go. First of all, we have to write the data properly. So we have to write what x depend, like we have to define what is x. So x represents the number of cars demanded on a particular day. Number of cars demanded on a particular day. So the first one is very easy. We can easily guess what we are asking. Neither cars are used. So that means none of the cars are used means it is simple. Yeah, you can easily guess x equal to 0. So we know the formula x equal to x and then e power minus lambda, lambda power x by x factorial, guys. So just now we found the lambda value is what? 1.5. It is given in the question. So 1.5 power x divided by x factorial. So as I said, use the calculator tricks and you can easily find the solution. So according to our problem, x value is what? 0. So e power minus 1.5 power 0 by 0 factorial. It is simply e power minus 1.5. So using your calculator, you can immediately get the solution. Okay, so the answer is going to be 0.2231. So the proportion on day which neither the car is used is 0.2231. That is around 22%. Okay, now the second part is very important. That's why I took this problem and we are moving for this video too. Okay, let us see. Some demands are refused. Some demands are refused. Okay, so when we refuse the demands, if all my cars are booked, then what I will do? I will refuse my demand. If some cars are there, I will give the order. Suppose 2 of my cars are booked. If the third person is calling for booking, I will refuse. Similarly, fourth person, fifth person, it goes up to infinity. So that means the probability of the number more than 2. Okay, if the calls are coming more than 2 calls, okay, if one call comes, I'll book one vehicle. If 2 car comes, I'll book 2 car. If the calls are going more than 2, the third call, fourth call, fifth call, etc., I have to reduce or I have to refuse. I don't have an opportunity because I have only 2 cars. Now it goes up to what? infinity. Now we know the classical formula. Total probability is what? Always 1, because I cannot find up to this. It goes any number of calls. So I can use the trick. Since it is it is a discrete random variable, I can use it as what? X less than or equal to 2, guys. So it is going to be very, very simple. I am going to find for what? Probability of 0, probability of 1, and then probability of 2. If I found all these three values, then and subtract with 1, I'll get what? The probability for the demands are refused. Okay, good. So now we have already written the formula. X equal to x is e power minus lambda, that is we can directly write minus 1.5 power x by x factorial. So as usual, guys, use your calculator trick, press calc, and then you can find what? The answer easily. Okay, press calc, put 0, 1, 2, you will get the answers. Okay, so it is going to be very, very easy, guys. So enter the value. I'm going to write the final answer and I'll make the video short and crisp. The final answer is going to be 1913. So there is 19.13% chances are there the calls are refused. The demands are refused. Okay, that's it, guys. So I took the problem because this part, if they ask if it goes to infinity, use the formula and change it and solve the problem in a very simple way. That's it, guys. Okay. Now let us focus into this problem. So these kind of problems can be asked in the small questions or sometime MCQs. What they're asking, now they are not asking you to find any probability, first of all. Okay. And none of the informations are given. So they give probability at x equal to 1, the value is given 0.3 and the other value is given 0.2. It follows Poisson distribution. Now our job is to find NP, or if possible I can find directly lambda. If I found, then using this I'm going to find a probability of x equal to 0, guys. Okay, let me explain. So what it is given to us, x equal to 1 is 0.3. Okay, then x equal to 2 is 0.2. So let us apply the Poisson distribution. So the formula is e power minus lambda. So x equal to 1, lambda power 1 by 1 factorial 0.3. Here e power minus lambda, lambda square, because x equal to 2 by 2 factorial is 0.2. So e power minus lambda into lambda is 0.3. Here e power minus lambda into lambda square is 0.2 into 2, 0.4. So it is going to be very simple. Now you have already guessed what you have to do. You just divide this two data, guys. If you divide this two data, it is going to be very easy. You can finish the problem. E power minus lambda square. I'll take this as equation 1 and I'll take this as equation 2. So 1 divided by 2 e power minus lambda by lambda, it's going to be 0.4 by 0.3. So all the datas will get cancelled. This will get cancelled, lambda. So immediately I'll get what? Lambda equal to 4 by 3. That's it, guys. So once you found the lambda, the problem over. Now according to my Poisson distribution, the formula is e power minus lambda power x by x factorial. So I already found the lambda, e power minus 4 by 3. 4 by 3 power x by x factorial. So what is asked to us? To find probability of x equal to 0. It is simply e power minus 4 by 3. Take your calculator and found the value. So these kind of problems they can ask you in MCQs also. They'll simply tell you to find lambda value. So just divide it or substitute it, you can easily get the solution. Okay, sometimes they can ask relations also like this. Probability of x equal to 1 is 2 times probability of x equal to 2. Find lambda. What is lambda? The same thing. In the previous problem, they have given different values and we substitute here. Here they have given the relation. You can just substitute the formula, find lambda value easily. Done. Yeah. So for the previous problem, my final answer is 0.263. So as a conclusion, what we say, they can ask the problem by giving n and p. Second type, they will say the word mean or average or lambda, etc. Then lambda is directly given, you have to solve the problem. And then third, they will give some relation. Just now we saw the previous problem, relation between like two different values, and from this we have to find lambda and we have to find some other values. So these are all the three kinds of problems can be asked in Poisson. Also, just now we see if it is something goes more than 2, like something infinity, use the formula